Hi everyone, good morning. In this lecture series, we are going to discuss about the topic in the clampers. So what do you mean by clampers? We know that clamper circuits are the electronic circuits that shift the DC level of the signals. So clampers, it is also known as the voltage restorers or level shifter. So these clampers are classified as positive as well as negative, and it includes both the biased condition as well as the unbiased conditions. So it is nothing but the combination of the resistor along with the diode and the capacitor. Sometimes it employs the battery to have an additional shift in the signal level. So here the main thing, the working of the clamper circuits depends upon the variation in the time constants of the capacitor. So tau is equal to RC. So that has been chosen large enough in order to assure that the voltage across the capacitor, at the same time the variation in the outcome of changing the current path of the diode with the change in the input signal polarity. So the magnitude of the time constant is tau is equal to RC. So this is the classification. So we are having two types of clamper circuit. One is positive clamper, another one will be the negative clamper. So this is the diagram of the positive clamper. So here we are having the capacitor, diode and the resistor. So here we are having we are having an input signal. So we have taken the amplitude of 0 to Vm, that is amplitude with respect to that of the time. So it will shift above the zero level. So that is termed to be as the positive clamper circuit. So in case of the negative clamper circuit, what I have mentioned in the previous positive clamper, just it goes down from the zero position. So that is the difference between the positive clamper and the negative clamper circuit. So the next one we are going to see about the positive clamper circuit with biasing. So what happens means, so suppose if the input signal is given, so we have taken the amplitude. So here from the figure itself we can say, due to the biasing, what happens to the output waveform. So it shifts from 0 to 2 Vm. So that is termed to be as the positive clamper circuit. So this is termed to be as the positive clamper. So the next one, in case of the negative biasing. So in the case of the negative biasing, it shifts down. So that is termed to be as the clamper circuit with the biasing. So this is the difference between the positive clamper with biasing and without biasing. So while coming to that of the negative clamper, so what happens to the negative clamper means, from the zero level it reaches the next level, and after that it comes down. So this in case of the biasing, the clamper circuits will be there. So here the negative clamper. So what happens to the negative clamper means, so from 0 to again it attains some amplitude. So that is termed to be as your negative clamper with biasing. So while coming to that of the applications of the clamper circuits, the first thing, it is used to identify the polarity of the circuits, and these circuits are used as the voltage doublers, and it helps in eliminating the distortions. So the main thing in case of this recovery time can be improved using the clamper circuits. So these are all the assessment questions comes under the clampers. So what we have mentioned in this clamper, let us go through this clamper circuits. So here the main purpose is the magnitude, that is tau is equal to RC. So that is tau is equal to RC is the time constant. So to reduce the RC value. So when the circuit is determined with the DC level, so that is termed to be as the clamper circuit. So here we are having so many clampers, that is in order, it has been referred to as an DC inserted. At the same time, so what are all the types that has been used in the clamper and how the application has been used. So thank you.